All right, now we're in the last section of Chapter 8, 8.7, Systems of Inequalities. So for this one, you're going to be graphing and then shading a region of the plane. The shaded region represents the solution set, which would have infinitely many solutions. A solution is any point, x comma y, that makes all of the inequalities in the system true. So what you have to do is graph and shade for both inequalities and then identify the overlapping area where you've shaded twice. And that represents the solution to the entire system. So taking a look at part A, we have y squared is less than or equal to x. So first you want to graph the equation version. Now remember that when you graph inequalities, if you have the or equal to, you do a solid line. If you have the strictly less than or greater than, you do a dotted line to show that the graph itself is not included. A solid line shows that the graph itself is included. So for part A, we're graphing y squared is less than or equal to x. So we're going to graph y squared equals x, which would be the sideways parabola. And I'm going to do that with a solid line. Okay, so I'm familiar with the shape of the parabola. Go to the origin, has some point that we probably are very familiar with at this point. When you graph this parabola, it separates the plane into two regions. The regions inside the parabola and the region outside the parabola. And the question is, which one do we shade to represent the solutions to the inequality? The way to find that out is by picking a test point that is not on the parabola itself, plugging it in, and see if we get a true statement. So I'm going to pick a pretty simple point. I'm going to pick the point 1, 0. So let me write that here. Test point. And this is just my choice. You can pick anything you want. To me, that just seems to be simple. X is 1, y is 0. So I get 0 squared is less than or equal to 1. That is true. So because the point I picked in here gave me a true statement, that means that every point within the parabola would give me a true statement. You only have to test one. So I'm going to shade in here. I'm going to shade kind of lightly because remember that what we're looking for is the overlapping shaded region that will give us the solutions to the entire system. The next inequality, y is greater than or equal to x, we first need to graph the line y equals x, which is the line that goes through the origin and has slope 1. So we're probably pretty familiar with this line. I'm making it a solid line to show that the line itself is included in its solution set. Now I want to pick a test point that is not on the line. I might as well pick the same one. Why not? I'll pick the point 1, 0. So x is 1, y is 0. So I get 0 is greater than or equal to 1. All right, that is definitely not true. So that means we don't want to shade the region of the plane that contains that point. So that region would be the region below the line. So what I'm going to do instead is shade above the line. So this would be the solution set for that one inequality. Now the solution set for the system will be where the shadings overlap. So for this system, that's a very small region right here. I'm going to try to emphasize it a little bit by shading more. So this tiny little slice here is the solution set for this system of inequalities. Let's try another one just to reiterate some of these points. So for part B, we have x squared plus y squared is less than or equal to 25, which will be a circle centered at the origin with radius 5. So let's go ahead and graph the circle. We will be making it solid because you can see the or equal to sign showing that the circle itself is included in the solution set. So that will be radius 5. So there's 4 points that I definitely know. If I go up, down, left, or right, 5 units. Okay, so now I'm going to draw on the circle, well, as best I can. Okay, it looks something like this. Oops, that's not great. Let me fix that. Okay, good enough. Kind of looks like a circle. Now we need to decide if we're going to shade inside the circle or outside the circle. So I'm going to test a point here. This circle does not pass through the origin, so I think I will choose 0, 0 as my test point. It's the easiest one to use when possible. And I get 0 squared plus 0 squared is less than or equal to 25. Well, obviously that's true. So I want to shade the region that contains 0, 0. So I want to shade inside the circle. Okay, I'm going to shade lightly because once again, we are eventually going to look for where the shadings overlap. The next one is y is less than or equal to x squared minus 5. Okay, so that is a parabola shifted down 5 units. So let's go ahead and graph that. Okay, so here's the vertex, and then I know sort of the general pattern of a parabola. I can go ahead and draw that in. I'm making it solid as well. Okay, now I need to know if I'm going to shade inside this parabola or outside this parabola. So I'm going to pick a test point. I will choose 0, 0 again. It's kind of the easiest one to use if you can. So I get 0 is less than or equal to 0 squared minus 5. Okay, so 0 is less than or equal to negative 5. That is false. So this means that I do not want to shade the area that contains 0, 0. I want to shade the other region, which will be on the outside of the parabola, which will be this. So this is a solution set for the second inequality. Now the solution set for the system is where the shaded areas overlap. So you can kind of see that's on these outer regions of the circle. So let me go ahead and darken that up and make it obvious. Here is my solution set. I'm going to outline it first. And then we'll shade it in so that it's obvious that this is the solution set for the system. Okay, so I'm going to put some arrows here so you can see this is the solution set. And we have one more. This one has just several linear inequalities to graph. So let's go one by one and see if we can plot these. The first one is x is greater than or equal to 0. That is referring to, first of all, the vertical line, x equals 0. So let me graph that first. And I don't really need to pick a test point. It's saying greater than 0, so positive, so I'm going to assume that I'm going to be shading to the right. I wonder if I can use the highlighter and see if this works. This could be a disaster, or it could be great. Oh, that's pretty good. Okay, let me use this highlighter to shade. So this is where x is positive. I wish I would have used that earlier. That's pretty easy. Okay, now the second inequality is y is greater than or equal to 0. So first I'll plot the horizontal line y equals 0. And then it says greater than or equal to, so that corresponds to positive y values. So I'll shade above that using my little highlighter here. So you can already see that these regions overlap for the first quadrant. So our solution set will be completely contained within the first quadrant. The next one is x plus y is greater than or equal to 1. Okay, so the line x plus y equals 1 is pretty easy to graph using the intercepts. So the x and y intercepts would both be 1. So I'm going to go ahead and label those first and then graph this in. So I use the intercepts. If you don't want to do that, you can always solve for y and do slope-intercept form. That's fine. Now I need to decide, do I shade above or below that line? Well, I'm going to test the point 0, 0 to see. So I have 0 plus 0 is greater than or equal to 1, which is false. So I don't want to shade the region that contains 0, 0. I want to shade above the line. So let me get this highlighter again. I'm going to shade above the line like this. Okay, so now we're leaving out that little corner of the first quadrant. The next inequality, x plus y is less than or equal to 7. I'm going to graph it in a similar way. This has x-intercept 7, 0 and y-intercept 0, 7. So I can use those to pretty quickly graph the line. 1, 2, 3, 4, 5, 6, 7. So 7 is here. It is solid again because of the or equal to. Okay, now I need to know, do I shade above or below this line? So I will try the test point 0, 0 again. 0 plus 0 is less than or equal to 7. Certainly that is true. So that means we are shading below this line. So you're really starting to see how all these shadings are overlapping. Oops, I wanted the highlighter. Okay, so I'm looking kind of like a trapezoid thing here. One more line here. 2x plus y is less than or equal to 10. I think I will put this one into slope-intercept form and see if that makes it a little bit easier. So I'm going to solve for y. by subtracting 2x. Okay, I have the slope now. The slope is negative 10. The intercept, the y-intercept is 10. That doesn't fit. Let's find the x-intercept. Looks like it's going to be, let's make this into 0. It looks like the x-intercept is 5. So let's start with that. 1, 2, 3, 4, 5. And then the slope is negative 2, so I can use that to find more points over here to the right. Also, I can go to the left. I'm seeing more points. Okay, so I've got this decreasing line. It goes to the point 5, 0. I couldn't fit the y-intercept on the graph. Okay, so now do I shade above or below this line? Well, I'll use the same test point, 0, 0. And I get 0 plus 0 is less than or equal to 10, which is true. So I shade below this line. So the main thing we want to see here is where do all these shaded regions overlap? So I'm shading below. So I'm kind of getting an idea of where it is. I'm going to emphasize it by outlining it and then shading it in really dark. So it's this kind of polygon region here. Okay, looks pretty good. Let me get this highlighter here, see if I can do this. Let me darker color. Okay, so I'm shading in the solution set to the entire system. Sometimes it's also called a feasible set, depending on what book you're looking at. Okay, so there is a solution set. It says, tell whether the graph is bounded or unbounded and label the corner points. Well, you can see that this is a finite area, it's a closed polygon. So the graph will be considered bounded. Oops, I wanted the pen. Bounded. And label the corner points. Okay, luckily these points are all very easy to see, to label them as xy pairs. So we have the point 1, 0, 0, 1, 0, 7, 5, 0. This is the point 3, 4. So those are